Finish the toasting on those bagels, put the cream cheese on, pour the coffee, do what you got to do. And let's get it started. GM.
Hello, world.
Yeah. We got a world coin mic for you. I'm ready.
Test. Hello, world. It's.
Hey, you know what? With these things, they actually are designed not to be underneath your chin because it shadows the mic. These are called lapel mics, and they go on the lapel.
Oh, thank you. Oh, that helps. Toby Meister. All right.
Sam's cooking up something crazy over there. Sam's about to change the world coin. No big deal.
Hey guys,
Probably
we're gonna get
nothing.
started. What's up, Relio?
GM.
We're gonna get started. Awesome.
A lot of computers.
Is Cloud on his way?
I think my multivariable calculus class was all computer. You had to run the model, the equations.
You wanna grab everyone over here, McJam? Rile the troops.
Bagel Mafia, get over here. We're getting into week 6.
You want me to blast the tweet out, Chase? Or is it queued?
Yeah, it's whenever we start. So
Perfect.
Linear algebra seems like it.
You got it. You got a template for it?
GM.
Okay, cool. All right, week 6. Let's get started. Bootcamp logistics. We got 1, 2,
Who's
3.
left? How we doing?
Hey, James.
If you want something done right, you gotta do it yourself. GM.
What's up, buddy?
Wow. I wish there was more weeks to this course so you could lead the additional weeks, Toby, because I know they're
Okay,
chock full of content.
Cooperson. What's up, Relio? How's it going?
I know, right? I really just want to see more of Sam's crazy demos, but, you know. David, some people have 5 day jobs, okay? You're a lawyer.
Schedule all the Zoom meetings on different days. Nobody will know. That's the problem is, like, can we reschedule? I'm like, no, you're gonna mess up my Zoom schedule.
If you wake up a different person on a different Zoom, is it really you? Fight
All
Club.
right. Let's get this party started.
GM.
All right, week 6, guys. How's everyone doing today? I like the hat, Vapic, Boring Company. Cool. How's everyone doing today? GM? Is that? Very GM. Okay. So today, same as always, week 6. We've got 2 more weeks of this. We're going strong. We're going to do some slides. We're going to ask questions. Hopefully we've got some cool demos this week. We built escrow contracts. Then we pop into week 6 slides presented by Toby. And then reverse classroom. Maybe we'll do another workshop if that works. All right, so who knows Web3?
Nobody.
We got Bapic.
I think I do.
Yeah? Okay. Well, we're learning Solidity Core. So I think we've gotten through like most of the language, a good amount of it. Solidity's like really small. There's not that many opcodes. So it's not like JavaScript where you've got just tons of core language features. Solidity is very small. You can read all the opcodes on a couple pages. There's about 100 something. So I think by this point, you guys have probably seen a lot of the core features of Solidity. And week 6 and 7 will get you kind of through the rest of things you can do, like proxy contracts and upgradables. Although I don't know if this is in week 6. That's week 7, right? 7. Cool. Real quick, I just want to talk about projects. So the way that we're grading the projects is if each day we're deducting 10%, and this is just to make it fair to those that are grinding really hard on the weekends to get them done. And one thing I would suggest is prioritizing projects over modules if you guys are falling behind, because that's what we're grading on. So just a little bit of strategy there. And then really just turn in what you have, right, at the end of the day. That might be worth more than turning it in way late. And we can work with you guys on that. So just a couple tips for late projects. So last week we announced the final project. So there will be a final for this course. Everyone's going to be building a full stack dApp, which means a front end, which we've been doing, and then a Solidity backend. So what are dApps? Uniswap's a dApp. Gnosis Safe is a dApp. Right? Anything that, any application that has some sort of front end and some smart contract protocol on the back end to interact with. This will be due February 25th. So it'll be 1 week after the last in-person session. And we're allowing teams of up to 3. So it's really beneficial to team up. I think you gain a lot with working from others. Maybe someone's better at front end. Maybe someone's better at smart contracts. Maybe someone's really good at the problem statement, right? Describing what you guys are solving and making it exciting. You can build something really cool, but if you can't sell it, then that's going to be a problem, right? And especially when you're at hackathons or if you're starting a company, if you can't explain the technology that you're building, why are people going to invest in it? So part of the rubric and the first thing that we're going to grade on is what's your problem statement, right? How compelling is the thing that you're building? And can you explain this? Can you pitch this? From then we'll go into front end. So we're able to implement a front end for this. We care about design, right? UI and UX is really important. It's usability. This is something that's been lacking in Web3. I don't want to diss MetaMask by any means, but it's still the most used wallet, and the UX has been crawling, right, to get better. So something to keep in mind, right? We want to make sure we have good UI UX. Obviously, this is a Solidity or Ethereum developer bootcamp, so you got to have some smart contracts on the back end. So we're grading on that. And then super, super important when you're dealing with money is testing. So we'll be grading on how well you test your smart contracts, the number of unit tests, integration tests, stuff like that. Any questions on the final project? Hey, Patrick. No, so it's 1 week after the bootcamp. So you'll be submitting a Loom video or a recording of your project, walking through it and explaining it, like a demo, like as you would at a hackathon. Yep. Cool. So a few of you have asked about the course completion certificate. So for those that pass the course, we'll be awarding an NFT credential. Passing in this case means 90% across all projects and final projects. So we'll pull together all your projects, and the final, we'll take the average of that, and if it's above 90%, we'll award you an NFT credential. Okay, cool, who cares, right? It's just a credential. Well, actually, with this credential, there's a couple things that we'll immediately be able to offer to students passing. One, that'll be an invitation to the Metacrafters Web3 Talent Collective. So Metacrafters is sort of like well, they call themselves a talent collective, but they're really a Web3 sort of organization that provides curriculum, assessments, education, but they also connect you with employers, right? And this is an exclusive hub that you have to be vetted to get into. Typically, you can take one of their courses, pass the assessment, and you get into the hub. But if you get through the ETH SD bootcamp and you get your NFT credential, you'll be onboarded directly, so you don't have to go through the assessment, which is really cool. The second thing is we'll be able to directly refer you to Chainlink recruiters if you're interested at working with Chainlink. So we've got a portal just for ETH SD where if you're interested, that'll get you kind of like direct access to recruiters, right? So you don't have to go through the typical process of applying. So these are the two things that we can immediately offer to students that will pass the course. So it's not just an NFT. It comes with some perks, what I was trying to get at. And then if you guys want to check out Metacrafters, it's metacrafters.io. Okay, cool. Week 5 recap. Talked about mappings, right? They're just hash maps, if you guys are familiar with other languages. They're infinite hash maps, or I wouldn't say infinite, but they have, was it 2 to the 256 number of slots? -1, of course.
256 slots.
Yeah, because you got that 0, right?
Goes up to 2 to 256
Yeah. We talked about events, and Toby made a great joke. But events are how contracts attempt to communicate to the outside world, right? Give a status of what they're doing. And then anything in the outside world, right, like what we're calling Web 2, can use these events to then send data back in, right? So it's kind of this like async feedback loop, or like event-driven programming paradigm. But smart contracts, like blockchains, don't communicate, right? They send events and then they wait for things to happen. So very asynchronous. And then the last thing we talked about in week 5 were escrows, right? So everyone knows what an escrow is by now, right? We've got an arbitrator, and we got a depositor, and we got a beneficiary, right? So 3 components there. The arbitrator is the middleman. Smart contract allows a decentralized way of sort of depositing, approving, and then accepting funds. So let's talk about the project submissions, the rubric for week 5. We always got the basics, right? Describe your project in your README, right? This is really important. Does it compile and run? For the front end, we kind of bubbled up those 2 React points into one. So are you using React properly at this point, right? We've graded on React for the last 2 projects. Do you understand your states, your hooks, your props? Are you using those, or are you doing some weird stuff? For design, we broke this up into 2 different categories, which is what you'll typically see at hackathons or in the industry. But, did you spend some time on your UI? So how creative, how pretty is your front end? And then did you spend some time on your UX, right? So how usable it is. Something can be really pretty, but like it doesn't work, right? Or it just like feels weird, and that's what we call UX. So 2 points for UI, 2 points for UX. If you're like unsure like how we grade these things, like definitely talk to myself or the mentors, and we can kind of like guide you through this. And then for the challenges, so 1 point if you were able to get off of the hard hat runtime environment. So were you able to deploy to a test net? In this case, we're using Goerli for our test net. There's also Sepolia, but we're sticking with Goerli for this course. 2 points for adding a way to Ether conversion. So way is like really nasty to work with. It's got 18 decimal points. It's like you have to count them, and it's just like frustrating, and no one wants to like, input a way amount. They'd rather just put in like 0.1, right? So do you have like a 0.1 Ether to way conversion or something like that? 3 points for adding a server to keep track of deployed escrow contracts. I know this was like a little bit confusing for some folks. What this really means is like, you can deploy multiple of these escrow contracts, and some of them are approved, some are not. If I refresh the page, is there some persistence where I can then see all the contracts that I deployed, and then see the ones that are approved and approve them, or see the ones that like already are approved and it shows like they've been approved. Like for some motivation, like if you guys have used Gnosis Safe and you deploy a transaction and you come back to the UI, it'll show you all the transactions that are pending and allow you to approve them. So this was kind of the idea for this persistence, if you will. Then 3 points for adding 2 new features to the escrow. So the escrow is pretty basic. We dropped in some ideas for features. So Open Zeppelin has a pretty baked out escrow contract that you could have pulled some motivation from. And then of course, something we'll always add is like, did you add tests to your features, right? Never deploy a new feature on a smart contract without rigorously testing it. That's a big no-no. Any questions on the rubric for week 5? Awesome. How about just like in general questions about mappings, events, escrows, Solidity, jargon? Mono? I'm looking at you. Tobes.
I thought I saw this question come up again. Oh, just so in Solidity.
Thank you, Toby. Thank you, sir.
Trained me well. So mappings are different from arrays. the memory layout is similar. It's an array, but accessing data is different. So Sam, in the last week in our workshop, demonstrated how you access the mappings, but think of them as you're not keeping track of anything in a mapping per se, because you can always get it because you need the hash, or you need the key to access the information. With an array, you don't necessarily know what information is sitting where in that array. You can go with a paradigm where you index it in a way in which you know what's there, but typically if you're keeping track of addresses or something, you might not know everything that's in there. So they're just two paradigms of thinking about how am I accessing data in an array and how am I accessing data in a mapping. And they're different, and like I was saying in the chat, you kind of want to limit the amount of operations you're doing in Solidity contracts because they all cost money. So that's something to keep in mind, and how those paradigms are different, and how can you efficiently use one and how can you efficiently use another. Typically in the mappings, the ding that you're going to get is the storage implication. As soon as you throw a mapping in your contract, your storage gets blown out, because you're allowing storage for all those mappings. If it's a dynamic array, it could be quite small and you build up over time. It's kind of tricky, and I think one of my goals is to get you thinking about how to design Solidity smart contracts, not necessarily whether or not you can call length on an array or not. It's how you're thinking about these things. So we'll do more of that this week and next week, but I know that was coming up. Arrays and mappings, a little bit different, and for hash maps, we lean on it a lot in Solidity.
Yep, definitely. Also, you want to try to avoid loops as much as possible, because loops are really gas inefficient, right? So if you look at some of the earlier NFT standards, or I guess you look at Open Zeppelin's implementation, they've got all these enumerables, right? Enumerable means it's going to kind of loop through things, and that's really inefficient. So always look for how you can get around using for loops, because those things are gas guzzlers.
I would support that. The problem is, in some of these modules, they make you do loops.
Yeah.
So I would say never, ever, ever do a loop in Solidity, but sometimes you have to. But if you have this mentality that you never use it, and then you try everything else and you have to, then you have to. But I know some of the early what were they? ICO factories that they used to make. You had to keep track of all those, and you had to loop through them. So however many of these contract factories you made, however many of those contracts you spawned would get saved, and you'd have to iterate through. So that's there. We have to use it, but I would echo the point that, as Chad said, if you can avoid using a loop at all, you should, and that's where the strategy of using mappings comes in. It's not perfect, but there's a consequence of either using operations to move through an array or using the storage implications of a mapping.
Yeah, definitely. So just something kind of to think about. Let's jump into demos. I got to look at the spreadsheet, but I know Sam, you definitely want a demo. Are you ready?
I think so.
Okay, cool. Yeah. Let's give it up for Sam. You go, sir. So it's a lapel, right? And it goes.
So the way that you use those things is it goes on the lapel, not under your chin, because under your chin you shadow the mic.
Just put it on your chest or something.
What's a lapel? Is it like a turtleneck?
If you're wearing a turtleneck, then you're a spy. No Archer jokes?
Oh, Archer.
So we
Okay.
almost put an Archer meme actually today.
So
We're so close.
My demo is actually going to be interactive if anyone wants to participate.
Oh, I'm down.
Get your laptops out.
Get your laptops out. Is that standard? Cool. Kosher? All right, so in the week 5 Discord, I put up connection information. Make sure I should probably have done that first. Okay. Hold on. Got to minimize things. Lots of things. What's that? Your Vim sticker. Oh, yeah. I actually didn't want to get into Vim, but it happened.
It gets into you.
Yeah. Okay. I can close my email. Yeah, definitely close Bitwarden. There you go. Okay. Yeah.
USB on the bottom there, the long wire.
Yeah, I'm just closing stuff first. Is this working? All right. Who else wants to participate? How many participants? Raise hands. Cool, cool. So in the Discord, I popped in the app URL. Go ahead and click that and see if the app is showing up. Actually, let me localhost here. There you go. App showing up should look like this.
Yes.
Cool. And then for the other information in MetaMask, if you go in and you go to first click MetaMask, and then click the account, and then click settings here. Actually, I'd like to go to this expand view, but go to settings here, click networks, and you can click add network. And then it will take you to this scene. There you go. And then you will add a network manually. So everyone got that? Show of hands, everyone on that? Okay, cool. And for the network information, I did pop it into the channel to copy and paste, but the RPC URL is that ngrok URL starting 0D47, and then chain ID is the number elite. I'm pretty sure that's what that means, right? 31337. I don't know. I put the currency symbol as test, which is like a lisp of test, but it also is just two T's around eth. So that's making sure I'm not actually accidentally spending ETH. And that should be it. Save that. Once you're done, let me know, and then we can get started. Oh, and then whatever account you're using to test with, go ahead and pop your name and then that address inside the Discord. Yeah, bump it up. Yeah, cool. I'm gonna go and go to the escrow app here. There we go. Hopefully it's not too bad. Okay.
You have 3 addresses inside the Discord.
Cool.
So we're getting loaded in.
Should be good.
Nice.
All right. Nice, nice. All right, so my demo is basically the escrow contract, but I'm going to create, it starts off with, I know that one of the things in the escrow contract was to have like a server that manages all the different deployed escrow contracts, right, and keeps track of it. So what I did is instead of a server, I created a smart contract to deploy the contracts and then manage the state within that. So a factory contract, basically. So I'm going to go ahead and deploy a factory contract, make sure I'm on the right account. Cool, cool. So first, got to deploy it. And what this does is it calls a function within the factory contract and goes ahead and deploys. Oh, no, haven't got to that yet. OK, so here we are. We're in the app. At the top, there's this hash now, which is the contract address. I'm going to go ahead and copy that part here, because that is going to get you into the app using the same contract. So I'm going to edit here, put that in there, hashtag, boom. OK, everybody re-click that.
Top one?
Yeah, the top one. You should be logged into the same factory contract. Is that correct?
Mm-hmm.
Cool, cool. All right, so yeah, the next thing that I did, which was interesting, was I created a, instead of just a single arbiter, I went ahead and created changed the contract out to actually have a quorum of arbiters. So let's figure out who wants to be the beneficiary.
I'll do it, yeah.
Okay.
I'll do it.
Famous last
Get
words.
rid of my precious tech.
Okay, so BAPIT's going to be the beneficiary of these funds. I'm going to also need to send some ETH to everybody. But before I do, let's go ahead and make BAPIC. Actually, let me go ahead and show you how it works by sending funds to everybody. So I'm going to go to Adrian right here, quorum of 1. This is just to send funds to you guys. I'm going to deposit, let's say, 1,000 ETH or TETH. I don't know, whatever. No requirement. So there's another thing is, I enter a beneficiary, a quorum of 1, a deposit amount, and then a requirement that must be met. But in this case, there's no requirement. Well, I actually probably should put something. Nothing, because I don't want it to like crap out. I haven't tested that. So I'm going to deploy this contract. You can see 1,000 ETH is going to be sent. Confirm. Down at the bottom, our existing contract is deployed. And it's voluntary as to who can arbitrate. For this case, I'm just going to arbitrate. So I'm going to assign that, hey, I want to be an arbiter. Boom. Now it shows one of 1 arbiters and my ETH address. And then I can approve, and the funds should be sent to Adrian. Funds showing up. If you're make sure you're on the right network. And cool. So Adrian's got funds. Let's go ahead and continue on. Make sure everyone has 1,000 ETH. So I'm going to try to speed through this as quickly as possible. Deploy, same thing. Arbitrate. This is just to get you guys some funds to play with. Okay. I was going to do a faucet, but that wasn't quite working out. So now Oscar should have some funds, and this is a way to dox you guys, by the way. No, I'm kidding. So there we go. Oscar, confirm you have funds. Yeah. Cool. Shows up. Confirm, approve, and then this should be BAPIC, I think. Is that what I clicked? I'm going to move this over here. Cool, and then Vanessa, last but not least. Cool. Arbitrating. So you can see, yeah, it's pretty cool. It's working, right? Working pretty nice. And so each contract is actually managed by the factory contract, so that way I can see all the state, or like see all the different contracts and then query into the state. So that's all working. So let's get to the multi-user arbitration. I think that's a word. I don't know. Okay, BAPIC. We're gonna send, let's say, oh gosh, I should probably max this out. Let's say 1,000 is, why not? Yeah. Come on. Yeah. And then since we have three, let's see how many we got. Head count 1, 2, 3 plus me. Or actually, no, I'll be out. So 3 others. Quorum of 3. And what should the requirement that BAPIC should do? Was it?
You're gonna have to pay me a lot of money.
Okay. Hey, this is very valuable currency. I just deployed this hard now. You're getting in on the ground floor here. No, how about makes one person at least laugh at his joke. Hey. There you go. So I'm going to deploy that.
We settled it, which is the best part.
So, all right, confirm. Hopefully this is all working. So cool. Everybody that's not BAPIC, I trust that you're not going to do this, BAPIC, because you could arbitrate yourself as a beneficiary. I didn't get that figured out. I didn't do that. That's a fix-up. But the other 3 of you, go ahead and click arbitrate and confirm that. It should probably, I don't think it's live, but I'll refresh. And then once we have 3 arbiters, BAPIC can tell his joke.
I don't think we can see the existing contract.
Oh, really?
Oh, maybe it's because of the hash?
You need the hash. Go ahead and re-click the URL.
I need the hash.
Yeah. The hash logs you in. I just did that today.
Oh, it's there. Yeah.
Cool.
Refresh.
Yeah,
Yeah, it's there.
this is gonna be fun.
I could arbitrate.
Yeah, please don't. Please don't. I didn't fix that. I didn't realize that this morning. Okay, cool. Okay. I got 0 arbiters. Arbiters. Just click arbitrate, then sign. Cool. We got 2. 2 out of 3. We need 1 more. All right. Before we get to the jokes, we need 1 more.
Thinking, man.
Okay, yeah. Let's see. What are we missing here? Is it Adrian?
Literally what I'm doing right now.
I think it's Vanessa. Were you able to log in, Vanessa?
Yeah, I was able to see the
Okay. Did it arbitrate yet? Just click the button arbitrate. Let me make sure. Cool, cool. Oh, no existing contracts. Are you in the right? Can you click the? Are you in the right network? Sam's net. There it is. Cool, cool. Showing up now.
Oh, I do? Wait, what?
Go down. Yeah. It's
Oh, I see, okay.
click that arbitrate button on the top contract here.
Got it, okay.
Cool.
I was like, I swear there was nothing here.
All right, I think we're good to go. So thing I didn't mention about arbiters is that they actually get 10% of the funds. So that's a little incentive there. But they only get 10% of the funds if their vote is unanimous. So if they approve all unanimously, they get 10% of the funds. If they disapprove unanimously, they get 10% of the funds. Difference between approve and disapprove is where the funds go, the actual deposited funds. Either approve, it goes to the beneficiary. Disapprove, it goes back to the depositor, which would be me. But if you're not unanimous, funds go back to the depositor, but you get no fee, right? So you guys want to act honestly if you guys want to. Yeah.
Is there a time limit?
No time limit. No. Yeah.
Like funds are stuck until.
Yeah. Unfortunately, that's a good point. I didn't think about that. All right. So Bapik, are you ready?
I'm gonna try. I'll go with ChatGPT.
Okay.
So, why did hi.
Hey. I mean, hey, it's up to the arbiters to decide.
These are so bad. These are so bad. Like, it's so bad. Okay, let me just come up with it.
Give him a mic, everybody.
GM, Bepic.
Okay, I just came up with one. I got it.
Cool.
What is a blockchain developer's favorite car? An EV, because it has no gas.
Oh. Hey, I laughed. That was good.
See? ChatGPT got nothing on me, bro.
All right, arbiters, what do you think? Did he meet the requirement? If so, click approve, sign that contract. Once you're done, if not, click disapprove. If not, go ahead and once you're done, once you're done with that, let me know. So, yeah,
This is
Yeah.
a nutty one, bro.
it's a little bit fun.
Really crazy how you made it interactive. This is like.
Hey, it says it's been settled. I don't know how it did that, but apparently it's been settled. Let's see where it actually went. I actually don't have that showing, which would be nice.
Oh, like a log.
But looks like I don't have 6,000, so.
And it looks like my balance increased.
Oh, so hey, that means that you guys all agreed unanimously that Bapik's joke was funny. That was it. Cool.
Someone laughed at it.
All right.
Damn.
Does anyone want to go into the code and see how that works, or? Cool. All right, it's a bit of a mess, but
Pump it up.
so how it works is, yeah, let me go ahead and just do this.
Yeah.
Oh, yeah. Let's do the lights.
Yeah, because it's hard to read on like black on black. With the
There we go.
screen.
There we go. Cool.
No, it's worth
All right.
It's actually all right. It's all right. It's like, oh, you're a legend.
Okay, cool. All right, we're good? All right, so the start of it all is just a couple of like helper functions at the beginning. This is just basically the local storage and hash of the deployed factory contract. This manages that, so like you get the current factory address by looking at local storage, or the URL. So that's how you guys were able to sync, right? That's how you guys were able to see the same contract that I deployed and read from it, right? So that's what those functions are. Here's the app component. There's a bit of state here. I was working on a faucet, but that didn't turn out to give enough money, so I ignore the faucet thing for right now. What I have is the account, the currently active account. So if I switch, let's say, if I switch like users at the very top, you see the account. If I switch users from my dev A to, let's say, dev B, you'll see it automatically switches, right? So that's what that account does. We have the contract count. This is the number of escrow contracts that are read from the factory contract, right? And then escrows are the actual data objects for each contract. Basically, hey, what's the contract's beneficiary, et cetera, right? Those are those objects. Of course, we have the factory contract address, which creates a factory contract. You know, we memoize based off of that contract address. We create a get contract, which is in a separate file, actually calls create new contract using that address, using the escrow factory API, right? We have some other handy functions in these contract helpers, deploy escrow contract, deploy factory contract. Those are all used, right? So that's pretty much it for my state. Of course, we have the signer. You're going to need that, which is, I think, just derived from the provider, Web3 API provider. Yeah, so there's a lot here. I'm going to try to skip through as quickly as possible to save time. We have this here, which is the changes the account, reads the current account that is selected. That's that goodness for MetaMask. And then here's the set signer, which when you change account, you create a new signer. This here is an effect that reads from the factory contract. This is what sets the count. This is what gets the faucet bounce and other stuff that I was working on, but that wasn't working. So here's the main function here. Get escrow and get escrows. Get escrows is just it loops through, gets the factory addresses that are stored in the factory contract. Let me actually pull that up. Escrow factory. It's very simple. In the factory contract, we have addresses, we have accounts, right? Because the thing that's interesting about Solidity that I didn't know is that you can't actually get the length of an address. At least I don't know how. If any mentors, if you know how to get a length of an array on a smart contract, then let me know. Otherwise, I actually just counted how many items are in the smart contract and made that public state. So my web app can actually read the count and then start looping and getting each element out of the array, addresses array. So that's what we do here. Get contract count, and then we start looping and say, give me address I, right? Another thing you can't do is you can't just say, give me all addresses from the contract because the array could be huge, right? So Ethers doesn't give you that access. So that's what those two states are. Very simple. I have a make escrow function, which is payable. And this just directly calls the to deploy the escrow contract over here, right? So it deploys an escrow contract, passing in the value that was paid, right? We pass in the same kind of function signature, arbiter count, beneficiary, and the requirement string, right? Once we deploy that escrow contract, we then save its address, or we get its new address, and we save that into the addresses, and we emit an event saying, hey, we did create this address, and we increment the count as well. I think that should actually, this might be a bug. It might need to be plus before the 2, but whatever. So that's it, and then I was working on faucet thing, but again, ignore that. Factory contract's pretty simple. So moving on, once we get each escrow, once we get the addresses, then we call this function to actually get the escrow data out of that contract. So we instantiate a contract using that address. We then say, give me the quorum. Then we loop over the number of quorum, and we go basically just get all the beneficiary data and all that stuff. Register some events so that way we can see when things are settled, retracted. I guess that's how I got that real-time update. Anyway, I'm trying to breeze through this as fast as I can because I'll just kind of go over the main parts. So the escrow contract works very simply. We instantiate saying quorum, all that information, right? Require, requirement, funding, etc. And we have a bunch of functions. That's quite a bit. We have the arbitrate, which is the button you push to say, hey, I want to be an arbiter, right? We have approve and disapprove. And I used heavily modifiers here to say, hey, you have to be an arbiter in order to approve or disapprove. You have to have not voted already, and the contract can't already be settled. The way I determine whether or not the vote, I just increment a yays value, state, if you approve, and then increment a nays if you disapprove. And then for each of these, we call a function saying, has everyone already voted? And if so, then we call settle. Has everyone voted? Just checks to see if the vote count is equal to the quorum. If so, then we settle the contract, and settle goes ahead and says, give me the consensus vote. That's actually pretty straightforward. We just say, hey, is nays larger than 0? And yays is 0. Then we could pretty much say with some confidence that the vote consensus is nay, right? Same with yays, right? If yays is larger than 0 and there's no nays, then it's consensus vote, a unanimous vote of yay. Otherwise, we return the vote, And vote is just a enumerable of nay, yay. So questionable, no or yes, right? So if the consensus vote is yay, we go ahead and send the funds to the beneficiary, right? We also calculate the fee, right? We don't just send the funds, we send the funds minus the fee, right? Fee is 10%. I did division because 1/10 is the same as 10%, and you can't multiply floats and integers. So that's why I did that. Payout arbiters, I do that first before paying out the beneficiary, because you guys did most of the work. I mean, the joke was great, but like, no, I'm kidding. And then, once that's done for an yay, we send to the beneficiary. Similarly, if you say nay, it goes to the depositor, but you still get paid, right? The arbiters get paid. If the vote wasn't unanimous, which is we send the funds back to the depositor, but we don't, you notice we don't pay out the arbiters. That's how that works. Pretty simple. All these other functions are just pretty much just internal, some view functions and stuff like that, and then all my modifiers. So not too complicated. There's probably more work to be done to make it more secure, like making sure that the beneficiary can't be an arbiter, things like that. But for the most part, that's the smart contract, and that's how it works. Any questions?
Microphone, please.
Yeah, quick questions.
Okay, I'll be super quick. For the stuff with the server, are you basically having like your own blockchain live on Ngrok?
Oh, yeah, so that was a pain in the butt this morning. Ngrok doesn't allow you to have multiple tunnels. So I needed a tunnel to the local host at 3000, which is the app, the DApp, right? And then I also needed a local host tunnel to the actual hard hat node. So I'll show you how I'm running that. We have the node running on port, where is it? Port something, 854, here we go. This is the DApp, and this is localhost 8545. So I have two Ngroks running right now that are pointing to two different processes running on my computer. One is for the node, and one is for the app. And the app is right here. So that's how that works. So the node itself is kind of the server. I didn't create any server. It's, Web3. We don't need servers anymore.
You're extending your local host, basically?
Yeah, I'm exposing my localhost through Ngrok. That's what I shared with you guys. Cool. Thanks.
Good job. GM.
Greg, are you ready?
Yeah, sure.
Okay, awesome. So we're gonna have one more demo.
Cool.
Does anyone else want a demo? No? Okay, cool. So yeah, let's give it up for Greg.
Put this right here.
While you're setting up,
Always put that in your pocket because it falls if you walk away. That's something I always remember. Mental note to myself.
Greg, just a quick question. Are you on Twitter?
Yes.
Awesome. Could I get your profile so I could tag you in this sweet photo we're about to get at your demo?
Sure. UX Greg.
UX Greg. There you are. Love it. Superman. Thank you.
So yeah, spent some time playing with diffusion and came up with a cyberpunk crow because I'm a huge punster. So as soon as I was thinking like, what can I do creatively? That. So the main thing that I've spent time on so far, aside from getting that image, was error checking. So once you put in valid addresses and amount of ether, you get some animated, this can work. If you try and put in things that are invalid, you keep getting the wrong state. Besides that, just showing the ether balance. One of the things that I'm working on is getting the back end working to be able to store these, but at the moment it's not working yet. So the main piece is quitting Visual Studio Code. Let's try that again. No, you're just totally gone. All right. Pretty much. All right, there we go. So the only really interesting stuff so far has been, frankly, going in and finding all of the different, oh yeah. Yeah, let's just hide the sides and hide the terminal. So the main thing has just been figuring out clean ways of trying to get these values, make sure they're valid. What I actually want to do at some point is make it so it's not simply checking length, but it's actually checking, is this a valid address? But so far this is working, and then using animation through class naming instead of any of the other methods, just to try and fit with the way we're going through this course. Besides that, I really haven't made too many changes. Oh, I did do the way to ether change, but that's been pretty much it.
All right. So the question I had was all the validation just local, or did you also do, I guess you would do that on the smart contract side as well, but was there any validation that you had to add in addition to what you already get from ethers and the network's validation on the data inputs?
No, but that was one of the things I wanted to add, because the error validation, when you put in things that are invalid into the contract, is it blows up in console and nothing happens in the UI. And so that was one of the things that I wanted to add, but I haven't yet done.
All right, let's get into week 6 slides. So let's bring up Toby. Give it up for Toby. If you guys want some coffee right now before, he's got a ton of slides to go through. So 1-2 minutes to grab a little coffee, get you guys energized, and then we'll jump into the slides. Do you need anything, Toby? Do you want some water or something? So I got it. Okay, cool.
The crow.
Yeah, Greg, that looked great. I want to see it work.
watching it, Chad. I'm watching it. Tell me when you start adjusting. Oh, no. Toby. Sorry, we were using your text as a focal point. It's not. It's
Oh, how do I?
still a little blurry. A little. Yeah.
What did the internet do?
Yep. Stop. I think that's. I'm not talking to you. I'm talking to Chad. Sorry. I think this is as good as we're gonna get. All right.
Hey, how do I get to the internet? Do I have to hit that modal? Anybody?
There's like a very fine, and then it goes. Exactly. Yeah. So this is good.
Hey, Chad, do you know how I hit the internet?
Like you just gotta like open up Google. It should take you to the captive portal.
You bit connect.
I had to turn my Wi-Fi on and off today. It wouldn't give me the captive portal until I did.
Okay.
Yeah, that's exactly what it was doing.
All right, let's do it. Let's give it a shot here.
This is happening to me, and I'm,
And mine is forced me to click on it to connect. I don't know why it's.
Is this it?
It looks like it is the portal. You might just need to restart. Okay.
No, I'm not restarting the computer. Do you know how long it took to get this thing going? Restart. What needs a restart? That is horrible.
This is like.
Have you tried turning it off, turning it back on?
That's what I don't want to do, Chad. Chase, sorry. Chad's looking. What's the portal?
Yeah. Let me get the IP address.
Toby.
Yo.
Toby, for me, I had to disconnect and reconnect.
To the internet?
I had the same problem.
Yeah, that's what Greg said. I just wonder if it's.
Yeah, it's disconnect from the network.
Toby 10.10.8.1.882. 10.10.1.8. And then the port number is 8882. 382.
VPN?
No. Does nothing work? That's funny.
Yeah, for me, if I didn't disconnect and reconnect, it would like constantly like have problems.
Kill audio just so we're not flooding the stream.
I did. Greg said the same thing.
It didn't give me the captive window though, so it may not work.
But like that, doing that doesn't work. You usually have to disconnect manually from the Wi-Fi. So like forget the network and then reconnect it.
Oh, really?
Yeah.
I wonder if they
that's what
changed it or
that's what I
something.
did.
Okay. I mean, I'm also not hitting it, so maybe that's. What a pain. No Wi-Fi. Delete this.
Can devs do something?
Really? Why not?
You gotta read it first. It has to be
That's probably going to be more React-y questions. I can help you with it.
Okay, for sure.
Could not be joined.
Could not be joined.
Sam.
Oh, there we go. I got it. That's. I totally had to forget the network for some reason.
I don't trust this dog, so I'm going to find advice.
Yeah.
There we go. Okay. That's good. Yeah. Thanks for the help. Together we win.
He's got enough bacon, so we're good.
That's right. We all gonna make it. Ready to go? Okay. Everybody, I think we're going to start this whirlwind of a talk, which is ironically not about Solidity. Yeah, but this is the Solidity week. So a couple things about the projects. Sam, I don't know. You could just have a helper function that calls the length on the array and then return that from Solidity if you wanted a little helper. But I don't know how to do that super better. Yeah. Well, in Solidity you would just say make a helper function. Give me the array length, and then in Solidity it would call it and then return it. You could do that. It's like a little hacky thing, but helper functions, they make the world go round. Also, I saw on Greg's, I'm not sure if it was, I saw 1%, and then I saw Sam was doing 10%. Did y'all have the split module yet? Did you do the split? No? Maybe that's this week. I think it might be this week. So just with that, with any time you do division or anything like that, because you can do floating point numbers, but you have to do it as if you were implementing floating point in computer science, where you have to keep track of the decimals and the whole numbers separately. So there's no float type in Solidity, but I mean you can use libraries to kind of get a floating point, but just keep in mind. I'm just gonna plug in because I don't want my battery I think is dead on this thing. Keep in mind if you're doing like division or you're doing splitting of amounts that you don't lose value when you do that. What happens if there's like a odd amount, things like that. All right, so this is going to be week 6. I think it's Solidity Core is what it said. This week is just all the modules are Solidity, practicing Solidity, doing a whole bunch of like little Solidity, kind of little. They're just small little programs to get you used to writing and working in Solidity. There's one task, which is the bucket challenge, which I'm going to review, and then I'm going to review the project, which is an ERC20 indexer and an NFT indexer. And the goal, so I designed this talk so that I would address the task and the project, and then if y'all want to get into like the nuts and bolts of Solidity after in the workshop, I was planning on speed running through all the modules just so you could see kind of getting the flow of how you would design some Solidity, or we can pick up with the unit testing that we didn't get to last week, or we can do the unit testing next week. Anyway, so this kind of came up, but just keep in mind these, look at you guys are going to be really impressed. Yeah. I missed no, they're just supposed to focus. It's supposed to focus. Anyway, I guess it's not as impressive as I thought. So this is 084. What are we on? 17, 18. So anyway, you won't go here, but your Solidity documentation is probably something you're going to have open in a tab and look through all this stuff when you have questions about what types are there or can I cast this thing, things like that. I always have it open when I'm writing. And then the Ethers.js docs, I think you're encouraged in the modules to use Ethers.js, and I know they use Ethers.js over Web3. I typically use Ethers.js when I build. You also probably want that one open, and they're on 5 right now, so you're probably not going to go to 3, you're going to go to 5, but I just wanted, those are resources that you're going to want to have, probably very accessible to you. So here's some reminders for Solidity. This is what people told me, and I'm going to tell it to you. So never lock value in your contract. That's like number 1. If you do that, you kind of failed. So how do you do that? Well, you write a contract that deals with money, and then you don't write a withdrawal like function, like stuff like that, right? You would catch that in unit testing, hopefully, but it's very easy to do. And then fail early and fail often. That was told to me by Rob Hitchens in the Solidity Bootcamp that I took. He's also user 5549 on the Ethereum Stack exchange. He's kind of prolific there. Or fail first. You'll see that a lot. You'll see like the first line of a function is require and then dump if it's not true. You want to test your code with automated testing. That's like going to be, we're going to keep hammering that into you. How you do 100% code coverage, we could debate that, but you definitely want unit tests for like everything that you write or extend. You want to make sure it's doing what you think it's doing. Don't have unlimited execution, unfortunately. So everything you write costs money. And why do we use Uniswap and not AirSwap? Anybody know? Exactly. So if you want to be a billion-dollar company, make sure it's cheaper than your competitors. Comment your code. You can look at this in the NAT spec in the Solidity style guide, but comment your code. You can comment it with decorators on describing what the function will take and return, but at minimum, just comment like, these are admin functions. This is the mint just so anybody else, because all this stuff is public, right? I can go to Etherscan if you verify that contract, I can read through it, and I would suggest you do that. And when we get to the proxy contracts, which is next week, I was looking through USDC's contract, and it's a pretty nice proxy upgradable contract for ERC20. Okay, so tell me, what is the Internet Engineering Task Force? That's the joke you should have told. So this is an organization that kind of builds out the standards for the internet, right? And so tell me what an RFC is. Yep. So these are basically technical specs for the internet. So anytime you want to write like, oh, I think internet protocol should work this way, or basically everything that we use, all the technology that we use in the internet, somebody wrote an RFC for it probably in the 70s and has iterated it to the point where you can go and look, how is a datagram laid out, things like that, right? So blah blah blah, they're basically just tech specs, more or less. Why am I telling you this? Well, tell me what an ERC stands for. What? Oh, I mean, I gave you the answer. Come on. What is it? Yeah, pretty close. So this is an initialism for Ethereum requests for comment, right? And so it's what is that, right? Yeah. Well, I got you there. It's a formal Ethereum technical standard or specification. ERC20. What's ERC20? Oh, it's a token where you buy it and then it goes up and then you sell it and then you buy a boat. It's true. Also, it's just a technical spec for an Ethereum standard, right? So what is an ERC20? Yeah, Vance? I can give you this one. Made it longer and more awkward, but okay.
All right, where does EIP fit into this? Or is that the next slide?
Great question. Yeah.
Well, I know EIP isn't the Ethereum improvement proposal, but I'm just curious, like, how does that fit with ERCs? Or how are they different?
So yeah. EIP would be like the idea of it, and then ERC would be the implementation, so the finalization of it.
So careful with the word implementation. ERC isn't an implementation, it's a standard. So it would be like the interface for it, but as Cloud said, EIP is like, hey, I have this idea, we should make a better token standard. Like maybe it would function this way, or maybe it would do this, and you can go to the Ethereum Magicians, I think, is that the one? I think that's it, where they discuss all the EIPs, like 1559. And Sam's got a question. I'm not going to take too many more questions because I got to burn through some slides, but we'll do it.
Just want to make note, EIP is internet proposal, is that correct? Or no, improvement
Ethereum
proposal.
improvement proposal.
Is that also worth noting that it's based on BIP?
Yeah. So this comes from, so the ERC comes from the request for comments from the Internet Task Force, and then EIP comes, as Sam said, from BIP, which is the Bitcoin improvement proposals. So that kind of comes from them. So they've been borrowing, nobody makes anything like, we all borrow. And I think that's kind of just how everything works. You see a good idea over there, especially in nature, and you're like, oh, okay, that's how you make a boat. Okay. What is an ERC20 standard? Anybody? Goes up, I make money.
It's a smart contract standard, and interface on which you can implement to create tokens.
All right, I
That's
asked
good.
the question poorly, but yes, that's true. Yeah, exactly. That's where I was going with this. Like units, fungible, so they're all the same. Like they're like technically a dollar bill isn't the same as another dollar bill, but we think about like $1, I'll exchange $1. I don't care which dollar I get, but they'll have different serial numbers. But I don't care if I get $1 and then I give it to you. It's the same dollar. I don't care. What's the 721 unique? What does non-fungible means? Right. One is not like the other, and typically we call that non-fungible. So these are all token standards. It's a token. I can transfer it. It's like this interface it has, a transfer function. It has mint. It has these things, but the differences are, like tokens, unique tokens, and then how about 1155? It's like kind of a newer-ish one, but yeah, exactly. So unique units, some fungibility. A way you could think of this, how it's set up in Ethereum or in Solidity, is that it kind of like a token has a balance. Typically, they use this in gaming, where you can say, okay, token number 0 is a sword, right? And there's 100,000 swords for this game. So the token is kind of, you can see how the mapping would work. The token would be, the ID would be 0, and then that would map to the amount of those that you can have on your game. So it could be like, these are kind of like RPC games, but you could have like a shield, a sword, a shield. These are kind of how these things are built. Or you could do whatever you want, but it's a little bit of a hybrid, because you could say this particular token has an index or a token ID, but there's also many of them, or however many I want. There could be 1, or there could be 10, there could be 1,000. So it's a little bit of a blend. So I like the idea that it's kind of like a hybrid. Okay, so here's the bucket challenge speed through. This is what you have to do are we all good? I'm going to start zooming. Yeah? Okay. So you have to do this. Not too complicated. You've already interacted with contracts, but you basically have to use you have to call a contract basically to hit one of the functions in the contract, and you're doing it with an ERC20 token. So the thing about the ERC20 token is you have this kind of like approval step that you need to do, which is a little clunky and odd, and we're all kind of like dealing with the aftermath of this. But if you want somebody else, it gives you the ability for you to approve another party to spend your token or to transfer your token for you, and that's what we call an approval. So basically what you want to do is you want to approve the bucket contract to pull an ERC20 token out of your, what do we call that? Out of your control, I guess. It's your control. Basically, all these balances are you control funds. Out of your control and into the bucket contract. And then when you do that, it will emit an event. If you get the event emitted, then you win, you pass, right? This is how they lay it out. This is kind of how they say you have to do step 1, transaction 1, and then transaction 2. So you'll have to do that. And I believe that's part of the grading. So we'll want you to do this. So here it is, emit a winner event by successfully depositing an ERC20 token into the smart contract. So that is not you from your wallet just depositing a token, one of your tokens into that contract. It's that contract pulling that value out of your wallet. And that's, I didn't even get into the paradigms of wallets, but you don't really have any coins in your wallet. That's an analogy that's pretty bad, but it's just a balance, right? You have a balance on somebody's contract. You get that balance to move, right? It goes from your associated public key to the contract. If you can do that, it will emit an event that says you're a winner. That's what we want. And then you can go and see that contract because this is deployed on Go Early, you can see it in Etherscan, and you can see that, oh, my address is associated with a transaction that emitted the event winner. And that's what we want to see. And that's what you'll have to do, right? So they give you the contract, right? And there's the contract in Etherscan, and it is verified, so you can actually look at it, and it looks like that, right? So this is the contract. It's called Bucket. It has an event called Winner, which takes an address. And if you can get this thing to run, then you win, right? And that's what we want, all right? So I'm going to go ahead and just speed run that right now. So make a new hard hat project. If you notice here, I'm using TypeScript, which I would recommend you do, and Sam supports that decision. Don't put your credentials in the project, please. Let's see, here's how I set up my env. If you notice, I put the Alchemy Goerli URL. It's the URL, it's not the API key. My private key is in here. Notice, I got a slide for that, right? Notice there's no 0x. It's not prefixed with the hex, but it is a hex number. And then this is my token that I deployed. So the whole goal is here that you're going to deploy a token to Goerli, and then you're going to get the bucket contract to pull a token out of your control to its control. So it's kind of a bit of an idea of how to deal with ERC20 tokens, the approval process, how you do intercontract calls and things like this. Okay, this is you guys probably all know this, but if not, I'm just going to go through it really quick. Hard hat config, you put the URL in here and also the accounts. It's a string because I think TypeScript was giving me some kind of problem with that. So you know that if you import everything from .env, it automatically gets injected into your hard hat, right? We know that. If we don't, ask me about it later. Please no credentials in here, please, please, please. What goes here on line number 1 of this smart contract anatomy? Right, what's all goes on here? Pragma, right? I'm going to go through. If you don't know this, just afterwards say, hey, you were going so fast. And I was like, yes, I was. But I will sit down and go through painstaking detail if you want. But we already should all know this. So I'm importing the ERC20 from OpenZeppelin. We can also do Soulmate, right, Chad? Transmission 11, shout out. So I'm just pulling this in because I'm going to use that as the I'm going to inherit all of that interface of what a ERC20 token is into my token contract. And then I just blast out with, please don't be, don't be like me, but also don't lie like me because I only put 1 in there. You should get, really should be two space. Thank you. And then I made this Tobes is ERC20. We haven't went over inheritance, but that's in this week, which is I basically pull in everything that is an ERC interface, or everything that's in this particular contract gets basically like injected into my contract. So I get all of the functionality of an ERC20 standard that's already been implemented. So this is where the implementation is different from the standard. OpenZeppelin implemented the standard. Typically a lot of people use it, and it's very easy to use and get access to. You can inherit it into your contract. Makes it really easy to deploy one of these things because this is the entire contract right here. It says, I have an initial supply. I'm going to make it 100 with 18 decimals, which is crazy, but we'll have to deal with these 18 decimals all the time, so you should get used to what that means and ask questions about, like, I don't understand what 18 decimals mean. And then you basically give it a name and a symbol, and you call the constructor on it. So this constructor for Tobes token calls the ERC20 token. It passes it the name, it passes it the symbol, and it in the constructor, it mints the initial supply, right? So you make an ERC20 token of BAPIC, and then you do the bucket challenge with that token deployed on Goerli. Are we ready to deploy? Yeah? No. Unit tests. They go in here. They go and test. Some of you already know this because you've been doing a lot of unit testing. If not, they go into the test. If you just skin up a default hard hat, it'll give you this lock contract. You can either use it or just delete it. Unit test real quick is just like, I'm going to test in here. I'm going to get the owner, and I'm going to test that the name and the symbol are what I passed in to deploy that contract. So very simple. I'm not going to go ahead and I'm not going to advocate that you test everything in the ERC20 contract, but you should test everything that you extend, right? So if you're augmenting that contract at all, you should test all that stuff. And here's the actual test. So that's this is the preamble, getting everything ready. And then So I'm describing the deployment of this contract, right? It should have the correct name, right? It should have the correct symbol, and it should have the correct decimals, right? Those are just very simple things that I passed, that I make that contract and I change that contract, and I want to make sure that that's actually happening. And you can do the negatives of these, right? You can do failure cases for all those. Okay, deploy, yeah, I think, yeah, we're ready to deploy. So the deploy script is something like this. These aren't very, I didn't change the like generic deploy or any of these other scripts. The whole point of this is you have to write the script for the bucket, like the bucket call, right? So this is just kind of very generic. You get your contract factory. The nice thing about Hardhat, if we're using Hardhat, is it kind of gives us access to the APIs really nice. I can just call Tobes because that's what I named the contract. And then I deploy this, I get the token instantiation. So that's the contract instantiation back, and I can call address on it to get the address. And then this is the typical like call that and then catch any errors that happened with deploy. And then you don't have to do this, but I just made a helper contract that I stuck in contracts as well. So this is my token, and then this is the bucket. And I just pulled from Etherscan, right? That's the exact same thing. It's got the interface for transfer from. That's how you transfer a token. So that's the function definition or the signature of a transfer from for ERC20. And this is the actual contract for bucket that's deployed. So where did I get this? I already told you where I got this. Yeah, Etherscan. And then I just make a script for that. You can make a task or a script. Anybody know the difference between a task or a script in Hardhat? GM. I always write. I mean, you could look it up if you guys can figure out why I would do one over the other. Please tell me. You can just use scripts, but you can also do tasks. So it's up to you. There's a difference. It's like you could do this or you could do that, and yeah. So what Cloud was saying is one of the accepted paradigms for tasks are like one-offs. You're just doing one specific thing, like maybe you're updating a contract with a certain value. Scripts are going to be a larger implementation, like you're deploying or you're doing some kind of automated process or repeated process. If you can figure out a big delineation why you'd use a task or a script, by all means go ahead. Or if you know somebody that's a really like Hardhat user and they can tell you, great, you should share it with us. I always just use scripts, and I don't use it for like heavy duty stuff. It's more like deploying, and then a couple of the other tasks I did have to for next week. I can show you like how I bricked the governance contract and had to like do a complicated task to undo it, but nothing crazy in here, right? We import everything from our .env. This is the top of it, and this is the answer, right? So I'm not going to show you that. Again, it's the same thing. This is our config. I'm bringing in the URL, and I'm bringing in my private key and using those. Again, this is the env. I guess I'm hitting you over the head with bringing this stuff in from the environment. So do we need to run this, or y'all get the idea? I know this is a very poor description of what we need to do, but I want to get you to the other stuff. And this is something that it's all explained. You can read through it. You can do it yourself. But this is basically the process you would go through, right? Bapik has a question.
Hi. Quick one. How are we importing the Open Zeppelin ERC20.sol into a smart contract that already exists?
So, well, no, it doesn't already exist.
Well, yeah, we're deploying it, yeah. But, yeah, just.
Why are you gonna make me go back this far?
There we go. Yeah.
This is my contract. I wrote this. Right.
Tobes, yes.
So what I'm doing is when that gets deployed, or when it gets compiled. The nice thing about Open Zeppelin's in ecosystem is if you give it this import this way, it will go and grab it and bring it into the contract.
So does it kind of like get injected into the ABI?
Yes, it gets pasted in. If you look at these, you can do a flat file, which which will show you everything that's in your contract. But if you were to do that, it would be all of the ERC contracts are above it, and then it would the last thing in the file would be this. Sorry.
Okay,
just
cool.
Back.
Cool,
So
thanks.
it always gets injected into your code. So unless you're using a library that is already deployed, all that stuff gets pulled in. So there is a deployment limit, a size limit to your contracts. You can't make infinitely sized contracts. So this is a consequence. Like, you can't pull in everything, but especially if you're using this stuff, you can do stuff like minter ERC20s, burnable ERC20s. You can do all kinds of things, and you can all pull them in. It's just, it all gets added. And if you look at the ABI, you'll see it in there. But if you also do a flat file, you can see all the contracts that are stacked up that would all get wrapped up into the deployment. Yeah. Cool. Going forward. And do you need me to run this? I mean, I don't want to, but I think you're fine. No, I can run it afterwards if you want to see it. But it's basically going to be that script, right? npx hard hat run scripts bucket, right? So it'll be interesting too. If you like this talk, I'm focusing on what you have to do. But if you would prefer to get into actually what the Solidity was, like in the modules, let me know, because we can do that like the next time. It's just all that stuff is laid out for you. You can just read it. So I thought this would be a little bit more interesting for y'all. So you just let me know after, or Chad, what you prefer. But at the end of this, for this week, you have to do an ERC20 indexer and an 721 index, so an NFT indexer. So you have to implement both of those. So that's front end. Basically, it's got a front end project, right? So this is really Cloud's day to shine, but now it's mine. Anybody have any questions about what an indexer is? All right. It is it is ironic that their project for this week is basically a front end project, but this is the Solidity Core. So we can do a bunch of like Solidity stuff in the workshop. Yeah, Vans has a question. Question in the back. How much time do I got, guys?
Can you actually explain what an indexer is?
Yeah, this is gonna just this is a great question. Let's go into it. Okay, 20 minutes, perfect. I would like to demo these too, so I'm gonna kind of move fast. If it's not, raise it again if I don't get to what the indexer is. So these are basically like you can skin the same thing, but I don't want you to skin the same thing. There's just one backend Alchemy SDK call difference, but I would like you to kind of do two designs, right? And I'm not a front end developer, and you're going to see why, but I'll show you what it is. So we're basically going to compare and contrast these two, right? So here's the assignment. So you clone the repo, and then you're going to open the terminal, do this stuff. You're going to grab the indexer and go into it, install, and then you run npm dev start. The things to know about this one is they're using Vite. I'm going to say Vite clouds. I'm going to say Vite all day long. I'm going to say Vite. I'm going to say Vite all day long. It could be Vite. I'm going to say Vite. So Vite or Vite. And then they're using Chakra for the front-end framework. All right, so that's kind of what you're given. I think I've battled with Cloud behind the scenes to say, I think we're just going to stay with this for this one. You get to familiarize yourself with the Vite or Vite deployment framework, and also the Chakra component library. So here are your step 2. Project won't work yet. You need to load up your API key from Alchemy. If you don't already have an API key from Alchemy, you're gonna have to get one. You should have an account, right? Because you need to sign in to get this stuff, right? Okay, so what do we do here? Well, we don't do that, that's for sure. Bad, don't do that. We don't want to, there's a line to put in your API key. Please don't paste your API key in there. There's a line to put in your API key. Please don't paste your API key in there. You should pull it from the environment, but this is also bad. So we're going to get in a fight about that later. And then you build new features, right? So here's the layout, right? Add wallet integration. So we saw this with SAMs. You could, use MetaMask to interact with that escrow contract. So you need to hook up a wallet. You need to add some, basically UX features. Progress, whatever, some styling. Token balances are a little long. How do we manage token? So this is the whole, 18 decimal places in these ERC20 tokens. They're horrible to look at. Nobody likes them, but how do you help the user out with that kind of thing? Error checking, perhaps. I mean, Greg and both Sam were talking about error checking. How do you do that? So that's a good challenge for y'all. The image grid, you'll see when you pull it up, it kind of looks not great. How do you optimize, loading this thing up? ENS support, you can do all these, right? And these are all part of the grading, right? I'm going to do 4 or 5 of these in front of you, and then you got to do the rest, right? Okay, so git clone npm install, this is what you get, right? Notice this little sucker right there. See, I told you to take note of it. We will be basically in the app, right? The app JSX. I'm just gonna walk through what I did. You can judge me later over a beer, and then you guys can make it so much better, right? So in addition to what came in, I threw in a heading. I also threw in text, link, and a spinner. These are all from Chakra. And then I did not paste in my API key there. I pulled it in from the environment. Vite has a nice little handy way of doing this with the import meta.env or .meta.env, and it's very similar to React, right? If you prepend React, if you make an env variable and you prepend it with React, it'll automatically be pulled in. Same with Vite. Now I don't even know what I was going to say. So I'm saying Vite. Same with Vite. If you prepend it with Vite, it automatically gets pulled in. So that's just something that'll help you all out. Add a wallet integration. So you can use RainbowKit or whatever you want. You could use Wallet Connect, which is what you should use. I think RainbowKit uses Wallet Connect behind the scenes, actually. So you should Wallet Connect, but I want you to use MetaMask for this one because you have to pull it from the window. MetaMask is you've got wide reach, so you should know how to do it. And it's kind of clunky to use. I don't know, maybe Sam can speak to that, but you got to pull it off the window and you have to do a lot of things to make it work. So I did that just to see, how to re-implement MetaMask from scratch, which is always fun. So npm run dev. Does everybody know how to figure out how to skin up the hot server for some of these projects? Where I got npm run dev. I think they tell you this, but if you look in the package.json, it will tell you which start and build scripts you can run, right? So this one, they're using npm run dev, not start, but dev. And it kind of looks like this when you initially launch it. And so I implemented this little connect button at the top left there. That one. And then basically when you click on that, it calls handle connect. Handle connect looks like this. If you're not connected, go ahead and grab ethereum.request. And I used ethereum.request so that it wouldn't auto connect you, which is kind of a pain. So you guys can struggle with that. If I wanted to connect and then when I disconnect, have it completely wipe out the account. So you can play with this, but you basically get Ethereum off the browser window, right? So you can figure out all that stuff. Basically go to MetaMask, documentation, look at how to add a wallet to a dApp, and they'll walk you through all this stuff. But basically, if you're connected, run this method off of Ethereum that comes off of the window. You can either request this weird thing that I did. If you want to play with that, you can. Otherwise, you can just request request the accounts. There's nothing special in here. This is very bare bones. I just wanted to give you an idea what you're doing. So there's some hooks up here for setting state that are based off of if the wallet is connected or not, right? The app kind of looks like this. Here's all the state up here. Nothing very special there, but I'm off of the window, I'm grabbing Ethereum. So that's kind of the key there for MetaMask, because it sticks it on the window. Is it connected or not? Blue or red. And then the use effect, if connected is changed, we're going to call use effect on, and go ahead and fire off the connect function, which is also, does everybody know? I don't know if I don't want to get into the front end stuff, but if you want an async in your use effect, you have to define it and then call it. Weird, not great, but that's what we got to do. So the problem is we're not using Next.js for this one just because they already gave it to you, but we really should use Wallet Connect and, as Cloud said, Next.js. Okay. So there's no indication of request progress. So this will take a little bit. The whole point of this is to show you that Alchemy has some nice functionality for getting like wallet balances. If you wanted to get a wallet balance, you'd have to scrape the chain, basically, right? So this is a little bit of an optimized way to do that kind of thing, but it still takes a little bit of time, right? So how did I add? So did you see at the very beginning it said spinner? I added spinner. How do I do that? Right, well, at the top, set your spinner to false, or set it to true, and then run the function. You're going to get caught up in here and here, right? Those are asynchronous calls, so they're going to take however long it takes to make the network go, and then set them, set your spinner to false at the bottom. Everybody knows how to do this. If not, come talk to me afterwards. Nothing really big there, but that's just the way to show progress, right? Obviously. So it kind of looks like this. You shove in a address in there, you click the button, and it pulls up all the balances that you have on your public key, right? So we could also do a couple other things, just kind of nice functionality. You can make all of those little cards links to Etherscan to go look at them. But basically, you're going to be looking at the wallet contract or the ERC20 contract itself. So you'd look at USDC's contract or whatever you have in there. We can also clean up the balances a little bit. You can make your own function to clean up, like, are you doing 18 decimals, or are you putting commas in there, or how are you handling like large balances? If you notice, like I just gave you 4 decimals, right, rather than giving you 18. And then also, if it can't find an icon, it just doesn't show, or it shows something weird. So can you put in your own icon? And so I put in the Smart Piggies NFTs as a placeholder, which you can see here, right? So this hop didn't have an icon that was recognizable, right? So I shoved one in there. And so I kind of did these for you. I didn't do any error checking. For error checking for addresses, you can use ethers.js. You can also, so they have a type checksum for addresses. So you can use that as something like, even you don't have to check for 42 characters, you can too, but that library will say, not only is this the wrong length, but the checksum is off, right? And you can convert, what I would do is I would convert whatever they put in that field to try and convert that to a checksummed Ethereum wallet address, and then just make sure that that's valid, because you want the checksum version of it. And then you can try and do these yourself, ENS support and all those things, right? So a note on application security. If you notice at the very beginning when I said take note of that env file that they dumped in there, I don't know if they've changed this, but a month ago when I built this thing, they put the env file in there, right? And then I used it, but they didn't include that env in the get ignore. So I got this like nice handy little, we have some generic high entropy secret exposed on GitHub. I was like, oh, that's very nice. Thank you for telling me. It says, fix this secret leak. It's like, man, this is great. This is like some nuclear codes type thing. So what happened? Well, this is my git ignore. At least that's the one they gave me. Hopefully they updated it. What does it not have in it? Yeah, what did I upload? Uploaded my env. It was a pain in the ass because I had to go get a new API key from Alchemy. Not a big deal, but kind of a pain in the ass. So the env has this Vite _ API key. So if you prepend it with Vite, it automatically is available to you within the framework. And then a further note on application security. So does everybody know what a 12-factor application is? So do you? Yes. No. Yes, Sam does. Some people who don't, look it up. This is how you build applications that are secure, kind of what the industry expects. And this is why we still fail on application security. This is number 3 for configs for the 12-factor authentication. You want to notice this one here. It says apps sometimes store configs as constants in the code. This violates the. This is a violation of 12-factor, which requires strict separation from config from code. So the litmus test here is whether or not the config if you factor out that config, will it change the code at all? Can it operate without that? And it should, right? So I'll show you a quick demo between those two, and I will also show you that we still fail on application security. Check. Hey. I disagree. Yeah, I heard. Yeah, no. What am I doing? I just want to tell them what an indexer is. This one? Oh, this thing? I can use the other one. It's fine. It's going to be a little awkward. Thanks for the patience. Go to this site. All right. There we go. I think I hear it. Yep. Check. One. Yeah, that's great. Thank you. Okay. npm while we were running dev. Oops. I don't know why it doesn't help me out here. Yeah, please. Thanks. Okay. So. Oh, please. I wasn't good. Come on, buddy. Very not happy. Okay, we're all right. All right, so I connect this wallet here, right? And I connect like a real one because that has stuff on it. And if I click check ERC20 token balance, the indexer is just giving me everything that is in there, right? So it's indexing all of the tokens that I have. That's what the indexer is going to be. It's just going to grab everything that's associated with your public key and dump them out here, right? And so if you click on one of these, foam, yay foam, it just takes you to the contract itself. So you can, typically we're just forcing this UX because we want people to independently verify the things, not just believe everything on a front end. But you can see that this is in fact the contract that I want to interact with, for instance. So this is what you're going to build, or you're going to build it much better than this one. And so you can see this one has some stuff on it. I can go and click on all of these things, and you know they're from Etherscan. But I guess I didn't. If I throw in another address here, you can see the spinner. But you know, I think you all know what a spinner is. No, I want to do this. Yeah, exactly. I don't know. Docs all these things. OG account? No, not the OG account. I don't want that one. Y'all didn't see that. You don't know what I'm talking about. I'm just trying to find one with more stuff on it. This one maybe. Right. This one, you can see the spinner. Yeah, it's a little spinner. See, it's pretty quick. And the other one is, let's stop that. Let's do NFT, npm run. I want to show you one more thing. I know this isn't interesting. I want to show you the interesting thing. And then this one's going to look something like this. See, I changed it. It doesn't look the same. Please don't give me the same thing twice. Exactly. You're hired. All right, and then I want to do, I think this one has some NFTs on it. Let's do this one. All right. Ooh, it's chunking. Oh yeah, so this one, so these are a little bit more challenging because you can scrape all the data out of them, right? And this is the problem with these IPFS NFTs is they never load because IPFS takes too long. So you might want to think about that. But yeah, so here's some stuff I even got 1155 in there. And you can click on these as well, right? So that's what you're going to build. There's not so much Solidity in there other than the bucket challenge. All the Solidity is going to be practiced within the modules. I just want to hammer this point home for you all. All right, is this a secure application? Why? You don't know why. You're just trying to front run my question. ERC 20. You're trying to sandwich attack me. All right. This one right here. Let's go with this one because I think this is the one I was playing with. NFT Indexer. Oh no, it's the NFT. Sorry guys. Let's go back. Tell me why NFT. This one. Yeah. Okay. Tell me why this is not secure or is secure. Go ahead, Sam.
Is it the Vite config?
No. Maybe. But let's take a look. I'm just trying to run this thing. npm run dev. Right. Okay. That is filled with this.
Oh, okay.
Nothing really interesting. Too much, but good question.
Can I have a side question?
Sure.
Why do we have to connect our wallets to get the tokens and the NFTs? Because isn't that already public data?
Yeah, so I could do, it's a great question. So I can go to Ethers. Yeah, I think I'm on mainnet here. Who's in here? Who's in here? Give me transactions. Where are my transactions? Overview block. Transactions. Thank you. Thanks for the help. Oh, I need it.
Oh, is it your wallet's NFTs?
It's my wallet's NFT, but it can be anybody's, right?
The connected wallets.
It's Connect wallets, but, oops, sorry. Oop. That was, okay, now. But it can be anybody's. It doesn't have to be. But you're connecting your wallet to find yours, but you can paste in anything in there. Sorry, hit that double. These aren't very interesting because these are probably like just machines. Oh, hey, it's got ENS on there. So this person has ENS. So it doesn't have to be mine, but if you connect your wallet, it's going to automatically like pull yours. So so the indexer doesn't care. It'll do whatever you give it. It's just when you connect your wallet, it's going to I made it autofill the connected wallet and it will change whichever address is connected, and then you can click fetch and find what's up there.
Another quick point to that, Vanessa, is you can, instead of having the website provide an RPC provider, you can use the user's MetaMask's RPC provider so that they're essentially paying the cost to make the call. Because if you have a front end site and as the front end developer you put an API key, you're using that key, right? And you're getting charged for calls. But you can also just leverage the user, so you're pushing that cost off to them. In this case, it's Infura and it's free for MetaMask, but it's just a small nuance. Is that correct?
Yeah, totally. Yeah. It's a great point. So the thing that we're not talking about here is whose network you're using or which provider you're using. So Sam's in his escrow made his own network, right? He was running a local network and you were connecting to his network, right? If you're going to connect to Ethereum, you either have to run your own node and then connect with your own node, or you have to use some infrastructure provider. So in this application, because we're using Alchemy's SDK, we're going to use their infrastructure provider. If you use MetaMask, MetaMask defaults to Infura's provider services. You can also put in your own. Like if I was running my own node, I could, in MetaMask, set up to call my own node, and then all the calls are going to be through my own node. But you're always going to have to ask one of the nodes, give me the information you have on this public key, because it doesn't exist anywhere else, right? Unless you can index that off-chain, like you can use the graph or you can use some kind of backend to keep track of all this stuff. But if you're going to ask the chain for basically public information, you have to ask one of the nodes because that's who's going to give you the answer, and you have to get to that somehow. So MetaMask is going to use Infura behind the scenes, which, depending on what you want to do, if it's just a retail wallet, it's going to be for free. But if you want to actually use their infrastructure for doing anything more, you're going to have an account with them, and you're going to have to pay for it, maybe. Also, if you're using Alchemy, those are resources that you're going to there's a certain tier that's free, and then once you go above that, you have to pay, all right? So great question. Loved. I can go over really go into detail after the talk, but I wanna. The last point of this thing before I let you go, because it's 12, is this application secure? What information did I put into this application that may or may not be secure?
Key,
API key. Is it secure?
Well, if it's an ENV, possibly.
Right, it's in an ENV file. Is that secure?
Are you exposing it to the front end, to the user, to the end user?
Yeah, well, I mean, let you tell me.
You gotta join a git ignore and then add it to the .env.
It's already in the.
Yeah. Looks like it's on the front end.
So that API is on your
It's on the browser.
environment variables, but not.
It's invite, so it's on the front end. That therefore anyone can get access to the API key. Who's using your app? Is that correct?
Yeah, I'll show it to you if you don't believe me. I'm trying to find where it says it's statically. Yeah. I was just trying to find where it shows you where the build process is. I had it. It doesn't. Sorry, where are the modes? Build. Yeah. All right. I'll show this to you later. I'll show you actually the thing now. All right. What is this thing called? Invite API key. All right. So if I run it locally, you're like, well, it's protected, right? So let's not do that. Let's build it. Vite, how do I build? Yeah, exactly. All right, I built it.
That was fine.
Could be. Depends on how much beer we have. All right, so it's gonna build this dist right here, and that's gonna be public, all the public files, right? So I'm gonna serve as dist, and that's gonna be on 500, right? So let's go to localhost. Anybody ever done this before? You're trying to scrape out people's API keys? Yes. Yes, nice. All right, so what's in here that's interesting? Come on. It's like nothing works when you're on screen. Okay, so in here, there's all the code, right? If I want to go find this, I did it. I did it to myself. I was trying not to do that. Okay, I want to grab that. Okay. What does that say? Oh, you little bastards. Okay, I just put that in there. I didn't really, that's not for real, right? No, let's change it. Give me something.
21.
Come some slack, Jack.
Yeah. Chocolate cake.
My booty.
Is that booty? Booty, yeah. Okay. All right. All right. Let's do it again.
Yeah, show audience.
I know. We're almost done. No, that's just it.
There is coffee that is brewing.
All right, let's go back. What did we say?
Don't steal my booty. Wow.
Don't do this. Please. Well, I don't care. You can do it. But somebody else is going to use your resources, right? So what's the problem here? You're building a front-end application. You're putting in information that you're pulling in for the environment, but it's getting saved as a constant. And then I can show you this later, but it says here, I can't remember where, just because I don't want to waste your time, but it says that environmental variables that are declared constant during the build process get stored as basically clear text. All right? Yeah, Cloud's got something. Are we ready to fight, Cloud?
Oh.
All right.
And I hate that I keep pretty much but this is some of the powerful sides of Next.js again, right? So Vite is dope, bundles super quick, you're working in big teams. You would need a proxy server in order to get around this.
Man, you just gave the answer away.
Oh.
I was trying to get there.
Oh, I'm sorry. I didn't know that.
That's the answer, right?
The cool
That's the
part about
answer.
Next,
Where is this?
right, is in their pages directory, there's another directory called API. You can build the call in there, literally just call it to that directory, right? So let's say I had a file that was making a call to Alchemy, and I was passing my keys in there, and my side I can just literally say the next API directory to this one, and then that's my proxy. So I don't have to set up the node in Node.js. I don't have to do all that. Or if you're doing it with Vite, then yeah, you need a proxy server, which is just a server then. I had a question. Do I need a microphone?
Yeah, if you wouldn't mind, I think for the people at home. Who's not one? No
Check. Okay. So, proxy server makes sense, or having a server that you run that protects that sensitive information makes sense. However, if you are like 100% full into Web3, no more servers, and you're trying to just build like client-only apps that connect just to, I guess, blockchain as a backend, how would you go about obfuscating sensitive information like this? MetaMask?
Use theirs.
Yeah.
Use their infrastructure.
Makes sense.
Yeah. So you either build a server that makes the calls and then sends the information forward to the client, or use their infrastructure, which is, I think, hopefully where more of these, the design of some of these Web3 applications is going to be. You know, you connect your wallet, use your resources to interact. For hackathon, you're going to do this stuff. You're going to put it into environmental variable. You're going to get that going. You're going to smash out a solution, and you're going to show it. And you're going to get a lot of funding. And you're going to be rich and famous, or just happy, wealthy, poor but wealthy. So you're going to do that kind of thing. But if you're building in production, just know that you can't just stick in sensitive information and then build that, like build a statically generated site, go shove that up somewhere, Vercel, and then go service users, because somebody's going to use that and just say, oh, well, they must have not exposed an API key here, and you're going to be taking in a lot of volume, so you might be paying for that resource, and then somebody has access to your resources at that point. So just so you know, I think I lost it, but it does say, did it move again? Every time I leave this page, it moves? No, it didn't. Okay, so this variable is statically replaced during build. Statically replaced. It gets shoved in there, so don't do that. Okay, I know. I just wanted to hammer that point home, because we keep saying don't paste your API key into the code, put an environmental in an environmental variable, but still that's still not necessarily a production solution for y'all. Okay, so what Cloud said, do that, or if you get to production, you probably have a team and you can figure this stuff out. But for hackathons, it's great. Just put it in an env, but know that. And I also, the other one time when Cloud and I were talking about API keys, he said you can have different environment configs, right? So I didn't show you my key, which is in env, but env.production is a higher order environmental config. So that's what gets built when I call Vite build or npm run build. So I was just playing with this one for y'all, so you can see it there. But my key is in this env, and I'm not going to obviously show you that, but that's what gets pulled in, and that's what the indexer is using to make all those calls. Any questions? Because we got to move. I'm 11 minutes over. We will be here for another 2 hours. You can ask me all the questions you want. Sam, do you have something, or we're good to go? Okay, that's it for me. Yeah.
Awesome. Let's give it up for Toby. Mr. Tobes.
Yeah.
So we're about to break out, but before we do that, a couple words of motivation from Mr. James. So let's give it up for James, and then we'll go and build.
Okay. Right. All right. So this is not scripted. This is just something that happened in the last couple of days to me, and I realized that I had kind of the exact same conversation with 5 or 6 different people in my lives in totally different, separate areas. So some of you know me, some of you actually don't, but for those of you that don't know me, I'm a totally open book, right? So you're welcome to ask me anything about anything at any time. But I think the first thing I want to say is I am super proud of everybody in this room here today, because number one, you are here. And that goes for the instructors and everybody else involved in this project, because right, you look out the window and there's palm trees and water and sunshine, and maybe I want to be there, but we chose to be here. And we started off on this journey at the beginning of January, and some of the things that we said at the beginning resonate, I think, more now than even then. You are doing something incredibly difficult, right? I mean, it's not brain surgery, but it's hard. Like, we are asking you guys to do hard stuff, and it gets really annoying and it gets really frustrating sometimes. And for any of the bootcamp participants that are current and up to date and understand everything, that's great. I'm super proud of you. But I'm more proud of the people that are in this room that aren't quite there yet. And one thing that happens every single week, we get up here and we throw 100 resources at you, and we say, you know, come to us for help, and many of you do, and some of you don't, and that's cool. You're going to get there on your own terms. But like when we say, you know, any questions on last week? Silence. Any questions on something else? Silence. And in my mind, I'm thinking, you're lying. I know you're lying, because I know there's questions out there somewhere, because I still have questions. Of course. So I think, you know, you have been presented with an insane amount of content in a really short period of time. So remember that. But also congratulate yourselves, because you have pushed yourselves to be here today and to learn what you've learned so far. Do you remember everything? No. I'm sure you've forgotten stuff. I forget stuff, right? Am I the smartest, most experienced, best developer in this room? Absolutely not. And I guarantee you that literally everybody in this room can teach me something, because I don't know what I don't know, right? We all have stuff to learn. So we want nothing more than for you guys to finish, and finish strong. Are we pushing you hard? Absolutely. Because you could have chosen not to participate in the bootcamp. You could have chosen to participate in the Alchemy University course online and go at your own pace and finish whenever. And I'm not here to shame anybody, and if some of you ultimately don't finish and want to continue at your own pace, fine. We are here to support you, and we are going to be here for that. But what we really want is we really want you guys to dig deep, find the strength, keep going, and finish really strong. Now, are you going to have days where you just can't deal with it, and you can't code anymore, and you need to like scream or cry or run away or whatever? That's fine. Like, listen to your body, listen to your brain, take care of yourselves. But there's also time deadlines here. So when you have questions, come to me, come to the other mentors. We're here for that. If you literally want to call me and just like scream and bitch and whatever, that's fine too, because I have those same emotions. We all have those same emotions. But just know that like we're all here, we're all trying to do it, and use whatever resource that you need to do to get through this. If that means hanging out here for a couple hours and coding with everybody and having a good time, that's great. If you want to go home and code in the dark in your room by yourself, that's fine too. If you want to co-work during the week here at Edge with us, we've got people here every day. If you are not able to be here to co-work, but you want to and you have the time available, co-work virtually with us on the Discord channel. If you want to DM me and have a one-on-one and we just screen share at whatever o'clock, do it, right? Just know that we're all here. We've got your back. We're going to help you get through this. And maybe you're not current, right? Maybe there's someone here still stuck on module 2. I don't know. But if you are and you still want to finish on time, you have the ability to do that, and you've got the support to do that. So when you get freaked out and when you get pissed off and when you get stuck, just ask, because we're all in here together. We really want you to finish strong. We are pushing you hard. We do have expectations of you, but we also know that you can get there. So that's it. Let's have fun.
Thank you so much, James. All right, it's time to get hacking. We're gonna do a workshop